Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have 4 to the power of x is equals to x to the power of 64, and we solve this problem for all the values of x. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for a very unique method. I hope so you like this method, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem from this method. So here the first target is to move the constant terms into the left hand side, and we move the variable terms to the right hand side. So for this, first we move 64 to the left hand side, so that we will take 64th root on both of the sides. So when we apply 64th root, it will be written as 4 to the power of x, and its whole exponent is 1 over 64 is equals to x to the power of 64, and its whole exponent is 1 over 64. And now we use here another nice exponential rule. You know about that. If we have a to the power of m to the power of n, this is equals to a to the power of n to the power of m. It means that if we interchange both of these two exponents, it does not affect our final answer. And here further we write this exponent, this rule as a to the power of m multiplied by n. So we write this rule into these three forms. So here in the left hand side, we just interchange both of these two exponents, and it will be written as 4 to the power of 1 over 64, and its whole exponent is x equals to, in the right hand side we multiply these two exponents, and this 64 and this 64 are cancelled out by each other, and we get here x only. So further in the next step, so you see that we move the constant term into the left hand side, and now in the same pattern we move our variable term x from left hand side to the right hand side. So for this we again take x root or 1 over x power on both of the sides. So this will be written as 4 to the power of 64, 4 to the power of 1 over 64, and its exponent is x, and whole exponent is 1 over x is equals to x to the power of 1 over x. And now we again use the above exponent rule, and according to that rule we multiply these two exponents, and this x and this x are cancelled out by each other, and we get here 4 to the power of 1 over 64 is equals to x to the power of 1 over x. So here you see that in the right hand side we have exponent be the reciprocal of its base. So we need to make this type of same condition into the left hand side. So for this we need to do some working into the left hand side, and for this we multiply and divide the exponent of this 4 by 2. So this will be written as 4 to the power of 2 over 2 multiplied by 1 over 64 is equals to x to the power of 1 over x. So here by using the above exponent rule, we move the term 2 inside here, and we write it as 4 square, and its whole exponent is, we multiply this 2 with this 64, and it will be written as 1 divided by 2 times 64 becomes 128 is equals to x to the power of 1 over x. And further in the next step, you see here we have this 4 square becomes 16, and its whole exponent is 1 over 128 is equals to x to the power of 1 over x. So you see that again here in the left hand side we cannot get the exponent with the reciprocal of its base, so we need to repeat the above process, so that we again multiply and divide the 16 by 2. So we again multiply and divide the 16 by 2, so it will becomes here 16 to the power of 2 over 2 multiplied by 1 over 128 is equals to x to the power of 1 over x. So by repeating the above process, we again move to inside the term, and it will becomes 16 square and its whole power is 1 over. We multiply this 2 times of 128. We know that 2 times of 128 is equals to 256. So we get this is 1 over 256 is equals to x to the power of 1 over x. So here you again see that the 16 square is equals to 256 and its whole exponent is 1 over 256 is equals to x to the power of 1 over x. So now in the next step, you see that in the left hand side we make the exponent be the reciprocal of its base, so that now here we have time to equate both of the sides. So when we equate the bases, we will get here 256 is equals to x, and when we equate the exponents, we get 1 over 256 is equals to 1 over x. So from both of these two cases, we get only one value of x, that is equals to 256. So now in the next step, we just need to verify that is this value of x be the solution, or is this value of x be the extraneous root. So for verification of this value of x, we need to copy down given question statement. Here it is 4 to the power of x is equals to x to the power of 64. And here we substitute the above value of x on both of the sides and we check its behavior. And when we put it into the left hand side, it will becomes 4 to the power of 256 is equals to here again we have 256 to the power of 64. So here we need a little bit more simplification here in order to make both of the sides are equal. So for this we break the exponent of left hand side, and this is 256. We write it as 4 times of 64. We know that 4 times of 64 becomes 256, and in the right hand side we have 256 to the exponent of 64. And now here we move the term 4 inside the term, so this will be written as 4 to the power of 4 and its whole exponent is 64 is equals to 256 to the power of 64. So you know that 4 to the power of 4 is equals to 256 to the power of 64 equals to 256 to the power of 64. And now you see that both of the sides are equal. It means that the value x is equals to 256 is satisfied our given question statement. So finally we have the solution set of the given question is x is equals to 256. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.